Hello, everyone. We are back for another advent of Code with Nix. Today is day 2, and we'll be looking at some program alarm. Today is special because we have a guest, Isabel. I'm Elise, and we have a special guest, Isabel, who knows way more Nix than I do. Sorry, all the pressure. Why don't you introduce yourself, Isabel?
Hi, I'm Isabel. Thanks for inflating my ego with the next thing. And if anybody wants to maybe find me, I don't know, you can find me at isabelroses.com. I'm at Blue Sky, Acoma, all the fun things.
Cool. I'll put all of those in the description too. So make sure I have that right. Yeah, so I think, is there anything to say? I don't think so. I think we can just get right at it. So, as you guys probably know, I like to read out everything I see. Oh, maybe we can do this like old school. You know how, like in classes, used to take turns reading stuff? Maybe we can do that. Okay, so I'll read a little bit. Day 2, 1202 program alarm. On the way to your gravity assist around the moon, your ship computer beeps angrily about a 1202 program alarm. On the radio, an elf is already explaining how to handle the situation. Don't worry, that's perfectly normal. The ship computer bursts into flames. These are all linkable. I wonder. Okay. You notify the elves that the computer's magic smoke seems to have escaped. That computer ran int code programs like the gravity assist program it was working on. Surely there are enough spare parts up there to build a new int code computer. All right, you want to take the next two?
No, I'm really bad at reading.
Oh, okay, no problem. I am too, by the way, if you've seen me like trying to read stuff. An int code program is a list of integers separated by commas, like 1, comma 0, comma 0, comma 3, comma 99. To run one, you start by looking at the first integer called position 0. Here you will find an opcode either 1, 2, or 99. The opcode indicates what to do. For example, 99 means that the program is finished and should immediately halt. Encountering an unknown opcode means something went wrong. Opcode 1 adds together numbers read from two positions and stores the result in a third position. The three integers immediately after the opcode tells you these three positions. The first two indicate the positions from which you should read the input values, and the third indicates the position at which the output should be stored. So this is really funny because, I don't, do you know, Isabel, that I did like a couple of videos on assembly language programming for the 6502?
Yes, I watched them.
You watch them? No way. That feels so cringe because it's all reading a book. It's like doing almost nothing. Anyway, what's funny is like in assembly code, oftentimes you don't like get the value directly, right? Instead it says like the value you want is in this memory location somewhere else. So in a way, it's like tying these two things that I thought were totally separate into like something that may have something to do with each other. So it looks like here we're not going to read immediately the actual arguments, but we're going to get the position, and then we're going to have to dereference that and find out what the actual values are, right?
Yeah.
Okay. Where was I? I always have a problem where I forget once I start blabbing. Okay. For example, if your encode computer encounters 1, 10, 20, and 30, it should read the values in the positions 10 and 20. Right, so the first one is the opcode, the 10 is the position for the first argument, the 20 is the second position for the second argument. Add those values and then overwrite the position 30, which is the last one. Opcode 2 works exactly like opcode 1 except it multiplies the two inputs. So it's like does the same thing except it's multiplication. Once you're done processing an opcode, move to the next one by stepping forward 4 positions. Right, because we have to go 1, 2, 3, 4, and then we're up to the next one. So suppose you have the following program. Let's look at this. I'm not going to read this out, but yeah, here they break it down into fours, except for the 99, because 99 means halt and it takes no arguments. The first four integers, 1, 9, 10, and 3, are positions 0, 1, 2, and 3. Together they represent the first opcode addition because of this 1. And the two inputs, these are the positions, 9 and 10, and then the position of the output, which is 3. To handle this opcode, you first have to get the values at the input positions, 9 and 30. What position 9, which contains 30, do we count? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is 30. And position 10 contains 40. Add these numbers together to get 70. Then store this value at the output position, which is 3, right? That's this here. That's this one here. So it overwrites itself. So we overwrite the 3 because that's position, we overwrite the 3 because that's position 3 with the value that we just added together. All right. Well, anyway, you get the idea, right? I'm not going to read the rest of it. Uh, so any ideas on how we should approach this, Isabel?
Um, I'm immediately thinking we need to get the file and we should load it into in with built-ins.read. Then I would like to split it by commas so we have a nice list that we can manipulate.
I was thinking,
Um,
here, let me propose something to you. Like I like to build like the easiest thing possible, the easiest version of it possible. So I was thinking like, can we make like an input file like that's basically just 99? And then it reads the 99 and stops, and we're like, hey, we have a working version.
that's true.
Does that, do you think that,
Yeah.
is that okay? And then we'll call this puzzle input. So we don't actually have the puzzle yet. And then we'll make a default. Is that okay? Like, I'll call this the default one. I don't know if there's a better way to do this, but um, I was thinking that we do that. And then I always forget, so I made this cheat sheet here of like trying to remember how to bring in stuff. These are like boilerplate things, it feels like, where we need to get packages in. So we like just have something like this, and now we just have to like figure out what to write. Is this like you know this kind of stuff better than me? Does this seem legitimate approach?
Yeah, it's fine.
Okay. So now we need to, you said read in the stuff with read file or something, right? I think I did that
Yeah,
previously. Is that
built-in.read file.
so we can use Noogle read file. Look at that. Thank you so much for telling me about this. So often I'll just yeah, built-in dot read file, and we need to give it the file which was puzzle input, I think I called it,
Yeah.
right? Puzzle input, yeah, okay. So this will read the file and return it as a string, right?
Yes.
So now if I run nix instantiate eval strict, it read 99. Perfect. Um, so how would we probably want to? I was thinking of a construct where we sort of like make opcodes. Well, here, let's do the really stupid version, like process opcode, and we only check for 99, you know? Um,
Yeah.
Wait, what should we do? I guess so. Let's say process opcode. We pass in the opcode, and that's just all it does right now. And then if the opcode if opcode is equal to 99, is there a then? I think there's a then.
There is, yes.
Then halt, else, error. Is this how an if statement looks? I think so.
Yes.
All right. So now the only problem is we have 99 like this, and we know that the 99 is actually going to be like this. But let's like cheat for a moment, and then we move this up here, and we assign this to the puzzle input, something like this. And this is a string. I don't know. I'll make it clear that it's a string by doing this. And so then we'll do process opcode puzzle input string. All right, what do you think?
Um, well, 99 isn't strictly going to be at the end of the file. I mean, right now we know it is, but
Right, right. I just want to make the broken version like does this before, because then we're gonna have to turn this to an integer or whatever, but this is like just like cheating. Do you know what I mean?
yeah.
Okay, so it didn't like process equals opcode because I didn't put. Do you have this problem? Is it just me where I can't ever remember to put in semicolons, or
Yeah.
it's just me? Okay.
I mean, I got nil LS to bully me into doing it correctly.
Oh, well, this instantiate program's always telling me I'm wrong, but I seem to not get any better at it. All right, so it did halt, right? So now what I'm thinking is that we should be doing this, right? Because this would be correct. So we're going to need to process this string a little bit um, to make it like uh, to make it numbers. Does that make sense?
Yeah.
Uh,
Um,
yeah,
if we load in the file the first time, assuming that the entire file is going to be on one line, we could use the remove suffix built in. I think it's a built-in. I might be wrong. It might be lib to remove the backslash uh, n, and then you could use toInt.
strings remove suffix, this one or the
Yes,
built-in one? Okay.
I think there's no built-in if it's in lib.
I just saw remove suffix. Oh yeah, you're right. What's the difference?
They're aliased.
Oh, they're aliased. I see.
Usually the more specific one is the original.
I got it. All right. So you're saying like I could just like remove the suffix here, like as the
Yeah,
whole file.
yeah.
Am I able to just like overwrite the string? Can I just do like packages dot
I don't think you can because um,
remove socket?
Nix has hoisting.
It what?
It has Nix has hoisting, so it will pull up any instances of something happening to the top. So it would
Oh.
get confused if you try to redeclare something.
Oh, let's see the error we get. Um, what does it say? Attribute already defined. Okay. Well, that's good. I think this is like I get into a very lazy habit. Um, let's just call this clean, and we'll do this. But now it's I added like other things.
Um,
But yeah, we can just print this out. Let's see what this is without the n, hopefully.
yeah.
Oops, I did not call it. Remove suffix. Oh, wait. Remove
Oh yeah, you
suffix.
need to actually give it a suffix.
Oh, okay. Suffix first. Okay. And then so I give it just a new line. All right. That sounds good. Is there, I think I saw there was like at some point we can split this now, right? Because we have like something really simple. So now we're
Yeah.
basically dealing with like splitting a string. So what's a good way to split that? I saw there was like more than one split. There's built-in split.
Um, split string might work.
Yeah, that works better than the other split I used because I used just like split last time
Yeah, and I believe that uses regex, so it
and it
gives you
yeah, so you
the
get the
two things.
matches and everything, but split string seems to be a little bit nicer if all you want is just to split it with something. So let's do that. So while I'm typing that, how did you get into Nix?
Um, so I joined the Campuchine Discord server, which now I'm a moderator of,
Cool.
and uh, half of the people I ever seemed to speak on to that were using Nix, so I eventually just got lured in um, into using Nix basically.
How did they lure you in? Just because they use it?
Yeah, they all use it. They were like, "You're gonna love it. Keep, give it a try." And the first time, I'm gonna be surreal. I hated it. I think I jumped
Oh,
right into the
surreal.
deep end, and it was no fun. But eventually, I think it became more bearable.
That's so funny. What happened? Like, what was it like when you first jumped in? How did you do it? Did you just install NixOS on like a computer and you're like, what the hell is this? Or
Yeah, my Arch install um, died one day when I was in a lecture. So I decided, okay, I had enough of Arch. So I just installed NixOS completely, and it was my first time trying. I think I was there for like 12 hours just trying to get it running, and it was pretty miserable.
oh my God.
Probably don't jump straight into the deep end.
That didn't happen to me because I was more interested in the language. Like, so I didn't like sort of care about using the OS just right away. I wanted to know what this language did. So I didn't install NixOS, but I sort of did under Windows like WSL. Um, yeah, I know, boo hiss. But but yeah, like but then I read the documentation and it was like it was easygoing and then all of a sudden I was like this makes no sense to me. Like what happened? And that's when I decided to start making these videos because I was like I need more motivation to read this because I'm giving up because it's like annoying me. Um, so yeah, it's the documentation isn't always the easiest.
Yeah,
All right, so it looks like we have split now, right? And that's working, but they are strings. So I was thinking of maybe should I map them
I
to?
think you have the map for this.
Okay, so we'll do puzzle input equals uh, map. It takes the function, so we want to give it like I have this cheat sheet, right? To oh I don't have to int.
It's lib.toint. with capital I.
This is why you should just like be there all the time, a voice in my head. Think of how much easier life would be. Um, all right, so now this should,
You might want to redeclare, make
all
a
right,
new
right.
line under lib, I mean under packages, and then make lib equal to pkgs.lib, and then life is good. And then you would save yourself typing packages out every single time you use lib.
Do you mean I make a lib here?
Yeah,
Packages.lib?
yeah.
Yeah, okay.
I mean, you could also inherit it, but either one works.
Oh, inherit. I don't ever use inherit. So inherit uh
You
packages
need
dot
to wrap uh, the pkgs in uh, curly braces and then put a space lib. Uh, I mean like normal
oh,
braces. Yeah, braces are hard to name. Yeah, like that.
I call those parentheses. Maybe it's a UK
Parentheses.
uh
We just call them
American.
all different types of braces. Curly braces, the funny braces, square braces.
Ah, okay, squiggly braces. Got it. So is this right?
Yeah, that's what. Right.
Okay, so now I can just call lib. Is that right?
Yeah.
Okay,
And
cool.
then there's one above with the remove suffix.
With the remove suffix, right. Cool. All right. So now we've mapped it. So now I should be able to just see this. Look at that. I have so many less errors when you're in my head. All right. I'm getting paranoid that it's not picking you up, but we did a test.
We
Yeah,
did.
yeah. We're okay. That's just the voice in my head again. The other voice in my head, not you. All right. So now we have 99. Now let's go back and try to see like if we could actually process an opcode. So if we had, in general, what I was thinking like we want to have like a position that we process from, and we have the list. So like process opcode, and maybe we give it like the list, which is
Oh yeah,
like
I see.
the list, and we give it the position, and then it can kind of like do the rest, you know? Like, so it can get like the argument one, and then we get the element,
Built-ins.elem at.
and then we give it the position first, right?
I I actually don't know for this one.
I think I put it in my cheat sheet. List, we give it the list first, then the position. Okay, so it looks like this, I think. And then we can do argument 2. Oh, I didn't type it in right. And then we can do something like this. I think we have to give it like parentheses so it knows that just for precedence. Um, and then we can get the store position equals built-in dot element at L position plus 2. I think that's right, but these are all positions. So this would be arg1 position, arg2 position, da 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 da. Does that make sense? And,
Yes.
and then let's just, I was thinking like we just print it out first just to make sure it works. And we do like arg1 position is equal to. Can I put integers into string interpolation or
You
not?
can,
So this.
but you want to use toString on them.
Oh, so I have to call. Is that a built-in?
It is, but also you don't need to. You can also use toString without specifying toString. I mean built-ins.
Oh, it's like
It's a
imported
very
directly.
funny one, yeah.
So I can do this.
Yeah,
Do I need to put this in parentheses or no?
no.
All right. And then we do process opcode and we give it the puzzle input. I don't think I made enough puzzle inputs. Let me go back there. Okay, because it needs to be able to read at least. We'll assume that it has to be a valid program, like with at least one thing other than stop. Um, puzzle input and the position 0 to start. Does that look correct? Let's see. All right, 99. Look at that. All right. So if it gets a 99, we want it to halt. We want it to like do like uh, we'll make the opcodes like halt op equals I guess they all take. Should they all take the same thing? I guess it takes in an opcode and it also takes in. Should it take in the whole thing?
Um, so I'm assuming you're going to map over um,
Yeah, you mean like I'll make a map of opcodes, which is
yeah,
basically an attribute set, and we make something. And I think attribute keys have to be strings, right?
yeah. So you
So
can't have, even if it was 99, you'd have to prefix it with underscore, I believe.
you think so?
I do.
I,
I mean,
why
you could
why
try
does the nine
eval, but
why do we need the underscore?
um, just something I've seen from Nick's packages, they don't export any packages that begin with numbers.
Oh, that's probably a naming convention thing more than
It
let's
might be.
let's let's see. All right, so this would be like then I would give it the function which is like halt, all right? Something like this.
Oh yeah, this makes sense.
And
Then you
then
would only need to give it one argument.
yeah, then I would but then what when I call this, I'm going to probably always pass it the list and the position just because I want to do it like imagine one would be add opcode. Oh, we're gonna get to use currying. Oh my God. So, so add opcode, and then I think I can pass it the what am I doing? The puzzle input. What was the puzzle input? And I pass it the position. No, no, no. Let's see what happens if I just do it like this all the time. Let's try it. And then 2 equals multiply opcode. All right, so let's see if this works. And obviously these things don't exist yet, so we'll have to write them. So let's put in halt opcode, and all this takes is the halt. Maybe all it takes is the opcode, I think, and then it just says done. I don't think this is going to work. Something tells me I'm not doing this right. And then we have the odd add opcode, which takes in the opcode. Uh, but we're gonna need to call. Yeah, that's not gonna work. We're gonna have to pass in the puzzle input and we're going to have to pass in the position, right? But we'll pass that later. Yeah, puzzle input. You're like, what? What is she talking about?
I'm just trying to understand what's going on.
Yeah. Uh, all right. So here we go. Puzzle input and position. And it just says we're done. And then this one takes in puzzle input position. I don't think I actually have to pass this stuff. And let's say all of them just stay done for now just to make it simple so that we can test. So, what else are you doing with Nix now?
Well, I manage my configurations with it and I do weird side projects like Capuchin Nix, which is declarative theme management. Pretty cool, I think.
What is
I'm
that?
noticing you're also getting your colons done now, semicolons.
Yeah, I'm getting some of them done, right. So process opcode, this will be like our main, we'll just call this process. And this will be our main like function here. We take the puzzle input, we get L, and then we should find out what the opcode is, right? So opcode is equal to built-ins. Oh, it's the first one. This is the opcode, right?
Yeah, first one's okay.
Right. And then this is arg1, and then we'll have arg2, right? Here. Uh, and this is the store position. That makes sense. And then we want to oops. And then we want to find out which function to use, and that was in our, uh, oh crap, that was in our opcodes attribute map. So we do opcodes dot opcode. But opcode here this is going to be an integer because we mapped it. So instead, we want this to be a string. Opcode, opcode. And then now this is a function, hopefully, if we did this right. And then we can pass this function, uh, the, yeah, we don't need to pass opcode because it already knows, we already did the logic here where we figured out the opcode was 99 already. So we pass in the puzzle input, and now we pass in the position.
Um, don't you want opcodes dot um $ squiggly brace
Yes.
and then end it with that as well?
Oh,
Yeah, I think that's what you want because
how
that will
come?
go for the opcodes uh list from above, and then the $squiggly opcode thing will say from that from those select this opcode.
Ah, right, right. Because otherwise it means it's going to look for opcode inside of here. Like it's looking for
Uh,
opcode.
yeah.
Right, okay. Makes sense. So this is how you basically say find the matching string. Okay, let's see what happens. All right, something's not happy here. Uh, multiply opcode. That's because I don't know how to type. Done. All right. Well, we don't know which done it was, right?
Fingers
Hopefully it's
crossed
the
it happens
hopefully it's
again.
the halt done. There we go. Look at that. We're almost there, huh?
Right?
What do you think? So now is halt is actually sort of done. Should we do add?
Add seems good, yeah.
All right, let's do add. So, how would add work?
Um, well, add needs
The
argument 1 and
oh,
2 position.
right.
And I guess if you put that there, then you also have to take that as an input for halt. Um,
This sounds like I should pass in an attribute set with some things that are required and some things that aren't. No?
yeah, I was
Right?
thinking the same.
Yeah.
Um, you can use the underscore symbol, underscore colon, and then it will make it so that those things are ignored. But you do have to
Yeah.
put as
No.
many as there are for
I
lambda
think I
inputs.
think it would be nice. Like I was thinking there was some way for us to do currying, but I guess not. So let's do it the way yeah, let's pass in an attribute set and we'll have a puzzle input. Um, and these all have what? Oh, no, these are equal signs. Right, yeah. And then we have position equals. Then we have arg1. Oh, we didn't actually get arg1 yet. Should we
Yeah,
actually grab it here? No, we shouldn't grab it here because these guys. Hmm,
they'll figure out what to do, probably, unless it's common enough.
we'll see. Element at L, um, and this is arg1 position. All right? Yeah. What do you think?
Um, seems good so far.
Right?
Yeah, seems fine.
All right. So now what happens is these guys get a single input instead of two inputs. Um, now I guess we can just do this puzzle input. And is it commas?
Yeah, it's commas.
So it looks like this, right? In fact, we can say we don't care about anything.
Yeah, the dot dot dot.
And this means other things are okay
You
inside of
could
it.
also use the underscore thing
Oh yeah, but this
because
seems
they mean
easier,
the
no?
same thing. Oh no, I mean even when you have an attribute set where you ignore all of the inputs, you can still use underscore colon.
Right. Okay. I think I know what you mean, but we can do this, right? Oops. Right, because we have to change all of them. These guys are going to need more, but for now, just to make this work, we will just do this. Oops. Oops. I am really bad at my editor.
Hmm. Uh, you need to include the comma dot dot in the
Here.
yeah, and also the multiply one. Cool.
There we go. All right. So, hey, it works again. All right. So what we care about here now is arg1, arg2, and store position, right? And
Yeah.
we can leave that there. I don't think it hurts. And now we can add, right? And then we need to, why don't we just print out the sum for now? Oh, that's elixir, sorry. Uh, is that good? Or did I need two string?
Um, seems fine to do either or, but two string works.
Oops, we have to change the input. All right, let's change the input. So now we have the first opcode is 1. It's going to add a 1 and a 1 and eventually store it in position 1. So it should store a 2 here later, right? And then we'll do a 99. Uh-oh. So
Uh,
while evaluating 1,
oh
oh,
right,
oh,
because
because we
I
didn't update
args there.
that. We need to give it args, right?
Yeah, but I think we ended up moving all the args down, so no carrying.
So we call add opcode. So this is going to return add opcode, and then here it finds add opcode, and then it passes in this stuff. Um, so that should be fine, right?
Yeah, should be fine now.
So this is kind of currying because we're just returning a function, and then it's
Oh yeah,
adding stuff later. But
yeah, yeah,
sort of, right? I guess it's not great currying. Hey, hey, we're getting closer.
does work.
Okay. Oh my God. Can you believe it's been 48 minutes? How much time do you have?
I have until 12
Okay.
my time, so
All right.
that's
All right. Let's put on the urgency. Okay. Um,
still an hour and 12 minutes.
all right. So now we want to actually store something in the puzzle input, right?
Yeah,
Uh, so God, how do you manipulate um how can I take a map and then like make a new map where there's a change in a position?
this one's scary. Um, I wanna say you map over it
Yeah.
and then you map over it again, but that doesn't sound very elegant.
Are you saying there's no there's
Ex
no
just like exchanging
map
that I'm
put
aware
or
of. No.
something? Like sometimes languages have that. Oh boy. Where's the Nix map uh packages? Let's see. Nix packages lib. Is it called lib?
Yeah.
Built-in functions Nix packages. No, that's not. Where's where's my Nix packages?
Uh, you're looking for the manual?
Oh yeah, that's a good point. And then I wanted to find the library. Standard, is this the library?
Yeah.
All right, great. Just wanted to see if what they have in the map. They don't have anything.
It will be in less, I assume.
List manipulation, but these are not attribute sets. Oh yeah, 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 yeah. Oh yeah, why am I saying map? I keep saying map, right?
Yeah.
So, list, right. Where was list? Singleton for each, fold from the right, fold L from the left, list IMAP, list filter, concatenate map, flatten, remove, find single, find first index. Okay, find first, list any, list all, list count, optional, to list, range. Oh, this is just going to make a range. Okay, replicate, partition.
Right and wrong predate? That's interesting.
Yeah, splits elements into many lists, ziplet list. I think we're getting close to the end here. Sort, sort on, compare list, natural sort, take. So this might be useful for us. Okay, take and drop can be very useful. Sublist is very useful. Okay, I think we can probably make it from this now. So what I'm thinking is we need a function that basically process. Let's put it somewhere towards the end so that we can easily. So we want to do like replace, and we take in a list, and we take a position, and we take the new element, right? Does that make sense?
Yeah.
And so basically, we take, we construct it by making, we want to basically take up to position, add position, and then add the rest, which is like, what was it called? Was it called take? It was right after take. Sublist is good too, but I thought there was like take and, oh, drop, remove. We don't need that. And then we do sublist. So we do sublist position to end. So we get the length. Is it just called length, I think, right?
Built-ins are length, yeah.
Length L, just because we'll probably need it.
Uh,
And yeah,
ty
yeah. And then,
typo. You spelled length wrong.
uh,
But now you removed your semicolon.
that,
Oh
I'm
no.
tired. I'm tired now. Oh my God. Got no more, no more energy.
Uh,
All right. So we'll call it like front, and we'll do like what is this called? Lib.list.take, and we'll take let's see, we'll take position. How does take work? Here, count, right? So we don't want to include position. So if position was at 0, it would be 0. If it was at 1, we just take 1, right? So I think that's correct. Take, and then we pass in the list. Um, we already know the new element, then we want to do the rest is equal to lib.list dot sublist where was sublist? Index at which to start the sublist equals to position plus 1, right? Just in case. I don't think I need the paren there. Just in case. And count, which is length minus position. Is that right? I'll do the plus minus one in a second. And then we do the L. Okay. So let's think of the logic here. We want to skip position, so that's why we do position plus 1.
And
and
then,
then and then this is going to tell us how much is left from the position. So if the list looked like 0, 1, 2, 3, and we told it position is 1, then we want two more. So it would be length is 4 minus 1, 4 minus 1, 3. So we need to do a minus 1. Does that make sense?
yes.
Okay, I think. And then we do in, and I'll do my trick again, where we just, no, let's actually try to concatenate. Uh, it's plus plus, right? So it's front plus
Yes.
new element. What do you think?
It looks strangely correct.
All right, so let's try running that. I have a brain, I just don't have fingers. Uh, so we'll try our replace. We'll give it a list. 0, 1, 2, 3. We give it a position. Let's replace the 0 position with a new element, which is 99. Ah! What does it say?
Oh, it's seeing the minuses as a uh what are they called? As an actual thing.
As a what?
As a variable because you can have um variables with hyphens in them. But it's working.
Woo! All
That's
right,
the
let's
important part.
let's let's try the let's try changing position 1. Yay!
Oh my God.
And let's try position 1, 2, 3, 1, 0, 1, 1, 2, 3. Okay. And then 4 should break. But we don't care. What? Oh my god! It worked. But 5 will break. I can't type now. I don't know what happened. I must be with caps lock, right? Oh my god. All right, let's try it again. This should definitely break. Oh, okay, whatever. I will not ask any questions. I don't even want to think about it. So, here we go. We have a replace function now, right?
Yes.
So that means in our add, all right, what do we want to do now? We have a sum and we want to store it in this puzzle input. So we want to replace I forgot the name I called it, how I pass stuff in here. All right. Replace puzzle input, the position, which is the store position, right? With
Yes.
the new element. Replace. Could this be it? I think this is it.
Fingers crossed.
Yeah, okay, so now we have the add opcode, and then when we process, we will go to opcode, add, it does this, calls add opcode, and then add opcode is going to do this. It's going to return the new thing, the new the new map, the new list. Oh no, where do we still have add? Where where do we still? Did I not save it? What happened? I can't remember what we did here in the puzzle input. One?
No comments. I mean, there should be comments, I
No,
think.
but it worked, didn't it? Because it replaced. We said add. This is add opcode 0, 0. So add 1 and 1 and store it in position 1. Oh, it should be here. You should store it here.
Yeah,
And you're telling me you know why.
I'm pretty sure we said split by commas, unless we didn't change that yet.
No? Where?
Um, at the top. No, yeah, okay, we haven't changed that. It's fine.
So why is it storing it in position 0 and not position 1? Let's see. Let's figure this out. So
Maybe print out the list alone just to see if it's loading in correctly.
here?
Um, I mean, go to the end of the file and then just print out the raw, I mean, the first time we process the list. Uh, what is the list called? Just the
Oh, the
after
puzzle.
we
Oh, do you mean
after we
like,
do parseInt, yeah.
so basically you're saying
Yeah,
print
because
out,
I'm
print
worried
out.
that maybe we're getting a blank item inside of our original list.
Oh, okay, okay, okay. So you're saying puzzle input, right?
Yeah, puzzle
Okay.
input.
All right. Let's print out puzzle input. Just make sure we have the right input. That looks right.
Okay, so it's not that.
No, it's not that. But now we're inside. Okay, so we should let us print out what all of these things are. New map, new list. But instead of doing this, we will just we'll print stuff out. Oops. All right, so we got the sum right. So probably we want to print out the store position just to make sure we have that correct. And the store position is just store position. Do I need to string?
Yeah, because it's an int, I think.
And I didn't do my thing again. Store position is 0. So basically we're calling replace. Then why? Let me just call. Am I calling replace wrong? Because I thought we tested replace. Replace puzzle input. Store position with the new element. New list equals. How can I print out a list?
You can use toString on that as well.
ToString solves all problems. Hey, the new list is correct. You see that?
Oh yeah, yeah.
So, so somewhere else I'm screwing up.
Semicolon.
So add opcode and then process calls add opcode, passes in this stuff, which all is correct. I'm so confused. Wait, now it's correct. What did we change? It's working now.
Um,
Wait, am I crazy? Before it wasn't giving that, right? It was giving, yeah, you see? Like, now it's correct. All I changed was this. I put it here. What the, what the, what the? Okay.
too much
So,
elves in the computer.
so, someone watching will figure it out, right?
Hopefully.
This is the comment. If you could figure it out and you add in the comment, first person to do it gets a prize. I don't know what that prize can be. A Nitro gift subscription for 1 month. Okay? All right. You have to join the Discord server and you have to join Isabel's Discord server. It'll be in the
No,
description.
too
No?
much
Oh,
pressure.
okay. Just my Discord server.
Exactly.
All right. So now, look, we can just kind of copy this, except the sum is now multiplication. And now this works.
Um, I don't know if we have the multiply symbol in next. I mean, you can try.
Here, watch. Nix REPL 5 times 10.
We do. Let's go.
Yay.
Oh my God, 2.18.8. It's been so long.
What do you mean?
It's because I'm using Lex, and last time I used Lex, 2.18 dot like 3 or something was just released.
Oh, okay. How much does it drive you crazy that I still call this sum?
I didn't even notice.
Okay. Well, now let's change the puzzle input to use multiplication. It's going to multiply, this should multiply 2 times 2 and then store 4 here, right? It'll be
Probably.
400199. Oops. Why?
Oh, because you used the dot 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 to ignore them.
Yay. Let's
It's
try writing
working.
a different program just to make sure it works. So we'll use the 2 and then we'll use 0, 1, 2, 3, 4. We'll do the 4 and this will be the number 7. So it'll be 2 times 7, which is 14. And then it'll write it in position 1. Oh, position 1, is that supposed to be this or should it be 0? I think maybe I did all the
Uh,
positions off by 1.
yeah, it um two like two currently is position 0.
right. So when I said store it in position one, it should have stored it here.
Yes.
So I did all the positions wrong. So let's see. Store position, store position. And then when I call all of these, how come it's working then? Opcode, store position. I thought we tested replace. I'm a little confused why replace is here. Let's try running this. So I don't think I saved. Oops, I don't think I saved the default. I mean, puzzle input. No, I did. 204. Looks like I don't actually use store position. Let's store this in number 0, 1, 2, 3, 4, 5. They should put it all the way at the end. Oh, it did. But it's still plus 1. Let me see. 0, 1, 2, 3, 4, 5. But it put it over here, right? Do I still have you?
The confusion is getting to me.
Okay, so somehow it looks like the store position is actually putting it in plus 1 instead of where it should go. So let's try to fix that um, by making a very simple example again using add opcode. Let's go to default. I'm sorry, not default. Puzzle input and add. So we do like 0, 0, 0, and this next parameter is where to store it, right? So if I say
Yeah.
0, then it should put 2 here, right? It should be 2, 0, 0,
Yes.
0, 99. And let's try running it, see what it does. But you see that it puts the 2
Oh yeah.
in the wrong place, right? So
Yeah.
let's find out why it did that. It seems like it probably is replaced, but let's just see what happens here. Um, I guess we can just move this back over here.
This could be a next thing. Oh wait, no. No, it can't.
So
Remove
let's
it.
say this is the
I'm
new
convincing
list.
myself.
And let's just print out what we think the store position is here. Store position is equal to,
Your
uh,
debugging steps are so much more sane than mine.
oh really? How do you do debugging?
It's a lot of dash dash show trace and
I
fingers
don't, you know
crossed.
why I do this? Because I don't know trace. I have not learned trace.
Well, I don't think it's that useful until you get into NixOS rebuild and stuff.
Oh, okay. Well, I'm almost I'm still pretty early in the process, I guess. And then I have to call toString like you said here. I think maybe I have to do it on store position too. Yeah.
Yeah.
All right. Let's see. Store position is 1. But that's not what it should be, right? Our store
Um.
position should be this argument.
Oh, I think
Oh,
it's
oh, because
because
we
you're.
dereference. It's working. I just forgot how it's supposed to work.
Yeah, I think you did lm at twice for store pos, but you only need to do it once.
No, no, it's working. Because because store position is 0,
Yes.
but it we have to dereference it, so we're telling it store it at 1.
Is
So
that one of the ones that also wanted dereferencing?
yeah, let's take a look.
Oh yeah, even that one wanted dereferencing, if I read that line correctly.
Where is it? Uh, to stores the position in the third position. Uh, to encode data, it should read the values from 10 to 20, add those values, and overwrite the position at position 30 with their sum. Oh, wait, so do we dereference? Okay, let's.
I don't I don't think you do.
You run by starting to look at the start, you find the opcode, what to do, encountering opcode, right from two positions, stores the position in the third position. Yeah, there's nothing that says we don't have to, right?
Yeah,
Okay, cool, 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 cool. So store position, that is here,
would
and
just be
we should just do,
the second one. Or you could do that one too, yeah.
sorry,
Yeah,
second one. Oh,
which is still pause. Uh,
should it just be,
I mean, either one you can remove, so you can remove this one, yeah.
and then it's just pause 3? Pause.
Yeah,
Wait a minute, I'm confused now. Store position is
because
position
you
plus
were
3.
calling lm at twice, once in the
Ah,
let and then once again in the
right,
opcode stop block.
right, right. But now that I know what I'm talking about, I like removing it in the second one. No, we don't. Yeah, yeah, yeah. This would work, right?
Yes,
Yay. That looks correct now. Let's assume we fixed the problem.
fingers crossed.
All right. Yeah, we're getting lazy now, but I'm pretty sure we fixed it. Didn't I leave some crappy code somewhere that's not correct? Did I fix it again? Yeah, here. Let's move it back down again. Last time, I promise you, I'm talking to the code more than to anyone else. um, all right. Yay. So we have this. Did we make multiply work? I think multiply works.
Yeah,
And now what we need to do is, um, oh, and then when we get the halt, we actually want to get the puzzle input and just print it out, like just return it, because otherwise it's kind of like, what's the point? You know? At
yeah,
least, so when we reach the halt, it'll say halt, and here's the puzzle input. We won't process anymore. The thing is, now that we process, um, we call the opcode, but now we have to like do the next process. So this feels a little bit like recursion. I've never done recursion in Nix. Is there any secret to it?
recursion and Nix. I don't think I've done anything that weird yet. The idea scares me.
All right. So we have a new list, which is basically opcodes. It just gets this next one, and then we want to call uh, we want to call it plus one, the position plus one. Oh, so we're calling it twice. I don't want to repeat this code twice. Like what I'm thinking is we do this, and then instead of puzzle input, we give it the new list, and position is equal to. Oh, we need a way to keep track of position.
Um, my original idea for this was getting
No, it's
a
here.
length of getting the length of the full list, and from getting the length of the full list, we can then use lib.genList, and which would generate us a list starting from 0 to the length of the list. And then we could iterate over that list and use that
You
as our
totally lost
position
me.
trackers.
You totally. Wait, 1 second. Would since we're passing in position to process, right? We pass it in over here. Couldn't we just like do it
Yeah,
once
that's what
here?
I'm trying to say, yeah. You keep using uh you remove the first new list thing. Oh wait, actually, I'm not sure. Maybe.
Like, why
Oh,
wouldn't
now I'm
this just
confusing myself.
work? Because we're making a new list by calling it. It makes a new list for
Oh
that one
yeah,
opcode,
that with
and
recursion, yes.
and then now we're just calling. Well, it's not
Oh yeah, yeah.
recursion because I'm not calling process. I
Yeah,
should
because you're
call
not calling
process,
process.
right? So I should call
I mean, if you call
process.
process in
Look at
on
this.
new list, yeah.
Isn't that it?
I mean, yeah, yeah,
If recursion
yeah.
exists.
I think it does because you can get an infinite recursion error index, and it's not very fun.
So let's give it the input that actually supposed to work. Uh, there we go. I don't know what this is supposed to do. Oh, it's supposed to leave
Um,
this
yeah.
3,500,
We're
3,000.
also gonna need to, because this is comma separated, you're gonna have to change it to comma separated.
Oh, did I not separate? I separated
You were
by.
separating by spaces. So if you go to
Oh
the top
no,
of the
that's what you
file,
were talking about.
yeah, time to start swapping the commas.
Right. Okay. Like this.
Yeah.
Hopefully it works.
Yeah, this is what I was worried about.
Okay, but shouldn't it shouldn't it return when it hits the 99? Um, Here, let's how do I get to like interesting process new list equals oh, but we don't really yeah, this isn't really good recursion because we're always going to process plus 1 and that we actually need to halt. So we need the base condition, which is basically if 99 then stop, otherwise process.
Yeah,
Let's see.
which is partly why I had my idea of just cut the recursion entirely, generate a list, and just iterate over using that list. But I mean, that would not be very beautiful either, to be fair.
I mean, we could just do like process. We could sort of like new list is equal to uh, L, then new list, else, process. I think this would basically tell us no, because like if it's a 99 and we don't change it. All right, let's try it again. If arg opcode is equal to 99, then new list, then just return new list. Otherwise, process. Why is it doing that? How can it be? Because process, here, let's just do, it's always going into process then is the problem. If opcode equals 99, position plus 1. Oh no, it's not position plus 1. It's position plus 4, right? Because we have to skip other things. No, but it's still failing. All right, we're in the infinite recursion, but I do want to figure out recursion. How does the trace thing work, by the way? Is that something that could like actually we can put in here that'll print something out when it's executing this?
I've used trace maybe twice, and I've never really understood it.
Where's
It
my Noogle? Is trace in here?
trace should be, yeah.
All right.
Evaluates one and prints
Oh, that's
result E2.
great. So basically it basically lets us to uh ignore it. Yes, okay, I get it. This means we can do uh what's the first one in our puzzle input? 1. Okay, so we're going to first see an add. So what we can do is we can do trace, and it's going to trace evaluate E1 and print its abstract and return E2. So this is E1 because it's the expression I want to print out. No, 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 no. I give it a better expression. Well, why not? On standard error, then return E2. I don't understand why I need the second one though.
Yeah, that's what I've always not understood.
Oh, I see. So it lets you trace stuff beforehand. All right. Well, not as useful, but we can do it.
Kind of good how the that link came up first.
All right. So we have our new list here. Now we can trace. Now we can do trace new list, add new list equals new list. Okay, that should do it. Uh, Sorry, I'm probably boring you now. Oh, look at that.
Oh
Ah,
wow.
stop! Okay. Um, so interesting. Uh, it looks like it starts, no, uh,
That code's quite long.
yeah, but it'll break at some point. There we go. Okay. So it gets the new list after it replaces. So let's look at the puzzle input. It says 9 and 10. So it's going to add 9 and 10. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to add 30 and 40 and put it in position number 3. So position number 3 is 0, 1, 2, 3. So it'll replace itself. So that's right. It put 70 here, right?
Yeah.
Okay, perfect. So that part worked. And is the rest of it right? We still have 2, 3, 11, 0, 99, 30, 40, 50. Right. So it didn't fuck up the rest. Oops, sorry. Didn't mean to say that. Uh, and then um, and then it should skip and do the 2, right? So it should be position 0, 0, 1, 2, 3, 4. So then we should call um, 0, and then here we called it once, and then we do position plus 4. All right, so why don't we do a trace in here where we print out the position just in case. Ah, sorry. I feel bad that this is getting a little hard.
Well, it's advent of code, and probably not in a language they expect.
All right. Yeah, so we'll just trace here. Oh, I can put trace anywhere, right? Yeah.
Yeah.
Okay, so I can put it in here. Um, Position. I don't really know how to do this. I guess I can just call ignore equals trace position. Position equals to string position. And I'll just give this a 0 because we want to ignore it. Okay, and let's see what this does. It's probably an error. Yeah, undefined trace because it's built in. I feel like we can do this.
It's doable, just hard.
Oh, how come it's not printing out my process? It's not printing out my process. Let's see. So here,
Interesting.
yeah, this one works, so let's leave it. Let's just leave it now like this so that we can use it again later if we need. But then let's get process working. Process equals all this crap, and then we want to trace. Let's just do it the way, I guess, trace position process position equals toString position, and then we do our normal stuff. If All right. I think that will work. Let's just see if it compiles. It didn't like semicolon. Trace. Oh, God. I'm just trying to figure out what our position is as we're incrementing the recursion. Oh, interesting. It looks like we're not actually updating position. What?
Um, why could that be? We're taking input pos
Do we need,
process is saying pos
let's,
plus 4.
uh,
You need an extra semicolon?
why?
No, wait, hang on.
Oh yeah, because of the if
Yeah,
from the very beginning.
extra brace even. Yeah, words.
It was the parentheses. Look at that. Well, I mean, it stopped. We're no longer infinitely recursing. But I don't think this is the right answer, right? Because it should have been, so let's do this. And then we'll see what it's doing. All right. So the very first one. Oh, wait, look at this. We do have the right answer.
Ah,
Are we close? Are we close? What happened? Okay. It shouldn't be the right answer at this point. That's what I don't understand. All right. So the first one, we got 1, 9, 10, 3. So we're adding the 30 and the 40. It should show a 70 here. Yeah. So it's doing the 70. And then the second time it will add it to, it moves it to 4. So it does this. And then it has multiply 3 and 11, which will be 0, 1, 2, 3, and 11. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 3 times 50, uh, which is 150, and put it in position 0. That's not the answer. So somehow we're skipping steps here. Yeah, let's print out more here. Position equals this, and then we'll do opcode equals opcode. Input list equals list, and store position equals store position. I feel like I'm doing double processing. I'm guessing in like some of these or something like that. But why didn't it like this? Cannot coerce an integer into a string. Maybe this guy? Alright, let's see what this says cleaner. Position 0, that's good. Opcode is 1, right? That means add. Input list, that looks right. Store position is 3. New list equals 70, right? So now we have 4. This is why I'm confused how we got this. It must be our multiple oh no, they were adding again. This is the input list, right? And we see the 70 now. Oh, this is right. Maybe we are getting the right answer. Anyway, so we have this, and now we're going to add number 3. We're going to add 3 and 11. So that's 0, 1, 2, 3. Oh, that's the 70. 0, 1, 2, 3, and 11. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 70 and 50 together, right? And that should be 120 and stored in position 0. Oh no, this is multiply. 70 and it's going to multiply 70 and did I say 30? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's going to multiply 70 and 50. And 70 times 50 is 3. So we are right.
Thank God for Nick's REPL.
Well, at this point I have no brain power. So this is right. This is right. Next one is process opcode 99. This is the input. Oh, but look at this. We kind of screw up because we're returning something else. Input list equals, and it's no longer the right list. It's the original list. How come? Built-in opcode. Let's look at halt. Ah, because we're double calling puzzle input.
Oh, you might be getting
This puzzle
shadowing.
input. Yes, it's not.
Yes.
Yes. How do I say I want this puzzle input?
Um, sh it yes, because Nick's shadowing always prefers the furthest out one. So you're
Really?
just gonna yeah, you're just gonna have to give it a
Well,
different name.
but then all of these are screwed up.
Um,
Somehow they're not.
Nick's is very weird with its pickiness about
Okay.
shadowing. Like if you use what one example is when you use with the older Darwin, you could use with Darwin, and then if you also had with um lib.platforms, you would get Darwin overshadowing each other, and it would not be very fun.
Okay, let's just be very careful about these then. Does that look right? Input equals puzzle input. New list. No, that's not right. All right, I think that was the problem. Um, so let's look at puzzle input. We have it here, 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 here. Okay, okay. Yeah. So now we should be good.
Ah,
Did we do it
it
right?
looks correct.
Oh my God. Should we try it with the real thing?
Hey, why not?
All right, let's get rid of the trace. Should we? No, let's not. Um, and let's get our puzzle input. Um, okay, okay.
We might want to process it back into into a string, so we can use um.
What do we actually have to give this guy?
I think we need to give it the original, like
Oh,
becomes
no, it
with the
says what's the
commas and
value
stuff.
left at 0.
Oh,
So we just have to copy this number.
yeah, that's much more
That's easier.
sane.
Uh, wait, was it once you have a work for first step is to restore the gravity your puzzle input to the state it had just before the computer caught fire. Before running the program, replace position 1 with value 12. Wait, what? It wants me to change the puzzle input? Yes, it does. Replace position 1.
Once you have a working computer, the first step is to restore the gravity.
Before running, replace position 1 with 12. So this is position 1, right? And replace position 2 with the value 2.
That's so weird.
Because it's the 1202. So we need to add the 1202 to make it work, I guess. All right, we have this number. Should we try?
Yes, why not? Let's go.
Let's go.
That was
I mean,
getting painful in some of the
I
parts in the
think
middle
I
there.
think we
Was
were
the ending
getting
bit.
I think we were getting tired, right? Like
Yeah, and then we confused ourselves a few
we
times.
confused ourselves a few times, but I mean, there's certainly room to clean this code up, right? Like, um,
It's actually not that bad so far. I mean, I thought it could be worse at sometimes, and other times like, hey, it's looking better than everything I had in mind.
but wow, like this, I think we could clean up. Um,
Yeah,
but I don't really know how yet. So, yeah, like here we can, but obviously we can get rid of the tracing. Um, and then we get rid of this. The replace, I think this looks okay because it looks clean enough. It should probably be moved up in the code because it's more of a library feature we're writing for ourselves. So now when we run it, yeah, we still get the right answer. Um, but yeah, yeah, I think this is not terrible. Thank you so much, Isabel. I'm so glad this is the first time we've actually spoken.
yes, and this is what we chose to do of all things.
Can you believe that people actually watch this kind of painful stuff. This is how I always feel. I always feel like I'm doing something and then I'm like lost for so long and people actually watch it. Like, I hope it's helpful to people. But honestly, this is not like if you did this in another language, it won't be much better or worse, you know? You probably have some better library functions for some of this stuff, like replace will exist. But
I was shocked that replace didn't exist.
it probably does, right? Someone will tell us it exists, but
If it doesn't, then it looks like we're opening a PR to Nick's packages lib.
no. I think, yeah, maybe. Anything else you think we should mention?
Oh, I mean, you went with the recursion route.
Oh, yeah,
I
sorry.
I went about doing it on my own while you were doing it as well.
Oh, yeah.
I have my own one. I also went about recursion in a completely different way.
Can you send it to me so that we can take a look at it?
I can do. I technically didn't do um um some things correctly, so to speak. Like you did the correct thing where um you brought in a very specific version of lib. I just imported it from Nix from from the old-fashioned way, um, which is technically wrong, but
No,
hey.
no, this is yeah, it's not cool. Yeah, take us through it.
So I just got the raw from the file, and
Yeah.
then I removed the suffix for the backslash n, which would always come up from where I split by commas. Then I mapped over it, turning them all into integers. Uh, and then from there, I have this gigantic process which takes an input of a list and a position.
Mm.
From there, we get the opcode, we get the arguments, and we get the store position. And then we basically go over the entire, we then handle each thing essentially. So we have our sum, our place, etc. And then I stole my replace code from you, so you've already seen that. Um, then we have our run, which is basically the last step, and it's just saying we take a position, we take the list, we run process on it, and if we have in our output of it halt, then we just output our list input. Otherwise, we run it again with the position with +4 and result. And then eventually I printed it out with concat sep thingies. Yeah, you get the idea.
So
Words.
if I run this, I'll get the same thing. Oops.
File.txt won't exist. You need to change it to what did you call yours again?
Call what?
Input problem input or something?
Oh, puzzle input. Yeah. So file.text. Oh,
You
but it's
type much faster than me.
yay. I like yours a lot. I think this is like I wanted to avoid the else if a lot because
Yeah, I
I
think I went
hate
down a more traditional Nix style, where you went down a very different route. I like how you did it way more. It looks a bit cleaner.
yeah I think this is cleanabler, but yeah, I like just the more like clear recursive aspect of like process and then call yourself again.
Yeah,
But with a base case and I do have an if, but it's like base case and recursion uh condition. So it's saying like basically if the opcode's 99, I know how to handle it. I just return. Otherwise, it's divide and conquer. Um, All right. Well, thank you so much, Isabel. I love yours too. I actually think yours is more readable. Like, God, it looks so readable. It's like this is what's happening. This is what you're doing. But it is more of a constructive sort of feel, right? Like do this, then that. But I do like it a lot.
Yeah, I feel mine is more traditional Nixie, and then yours is
Uh,
more like I've just come into Nix, so I'm gonna do things a more my way. And I like your way. I think your way's better.
yeah.
I think Nick suffers from some of these, like, we do everything in our old-fashioned way type issue. So I definitely I think I actually prefer yours.
Well, cool. Well, I think I'll add both of ours to, do you mind if I add your code to my GitHub
Be my
solution?
guest.
All right, great. I guess that's it. And we're like just 4 minutes shy of the time you had turned into a pumpkin. So we
Yeah,
planned our problems perfectly.
apparently so.
Thank you so much. We're gonna add your contact info in the description. We just met like what, like a week or two ago? Like it feels like forever, but like it was very recent. We met on Mastodon, maybe? Is
It
that
was
right?
Blue Sky first, and then someone introduced me onto your account on Mastodon.
Oh, so cool. Yeah, I personally I prefer Mastodon, but Blue
I
Skies.
do prefer Fetty more, yeah, but Blue Sky is much more people.
Oh, there's more people there? Yeah.
Yeah,
It's just like, well, they're both like a whole different universe away from the
yeah,
other one, right? So,
yeah, exactly.
um,
Different genre, different messages, I guess.
yeah. All right. Well, thanks so much. Like and subscribe if this was helpful. And there's a Discord server like I mentioned. And I guess that's it. Thank you so much. Thank you, Isabel.
Thanks for having me.
Sure thing.